Today's session is called Transforming Project Delivery with a Construction Project Digital Twin, which is presented by Richard Humphrey, the Senior Director of Product Management at Bentley Systems. Richard is the Vice President of Product Management and Product Strategy at Bentley, focused on delivering construction solutions. He has more than 20 years of high-tech marketing and product management experience, most recently as a VP of Marketing at B2W Software, where he drove the marketing strategy for heavy civil construction products. He spent 10 years as a senior director at Autodesk, where he led the civil design and construction software business. He started his career in the AEC industry as project manager for the Army Corps of Engineers and Clark Construction, with a Master's of Science in Civil Engineering from Carnegie Mellon University. Rich is a lead AP and has worked with leaders in the building and infrastructure industries to drive sustainable design, technology innovation, and BIM VDC. So he'll be talking about how there's been a lot of talk about smart infrastructure and digital twins. Much of the current buzz is around IoT during asset operations and management. The session, however, will focus on the development of a construction project digital twin, which is the baseline for downstream asset performance digital twins. It will also look across all infrastructure, including civil and industrial projects, and how the development of a live 4D model is leveraged from pre-construction to construction execution and handover, and how technologies, for example, IoT, reality capture, 4D modeling, AI, machine learning, and robotics, are converging to enable the project digital twin and will transform the way smart infrastructure is delivered. In this session, the following objectives will be addressed. What is a digital twin? How do you develop and manage a construction digital twin? What are the workflows and benefits to the construction process of a 4D model digital twin? And what technologies enable the construction of digital twin? I would now like to pass it over to Rich, and so he can get the session started.
Great. Thanks for the introduction, Kirk. Hopefully everyone can hear me. So as Kirk described today, I'm going to describe how digital construction can solve some of the most significant problems that are faced during the construction phase of an asset lifecycle. And like you described, I'm specifically going to talk about and introduce the concept of a construction project digital twin. Before I get into that, I'd like to start with what are those big problems in construction, specifically the demand for infrastructure continuing to expand. However, the construction industry really still struggling to keep up, largely due by the lack of productivity that we've seen. I think many people may have seen this McKinsey slide before, but as it shows here, while other industries, particularly like manufacturing, have seen step function improvements in productivity over the last 25 years, construction has basically seen no gains. And it's clear that much of the productivity gains seen in the other industries is driven by new processes enabled through the adoption of technology. So we want to see that happen in construction as well. So if I go a little bit deeper in that productivity gap for construction, it's driven by three things here. First, project complexity, which includes the increase in design complexity, as well as infrastructure projects just getting bigger and more complex in size. But also, and maybe even more importantly, while this is happening, there's an increase in owners' delivery expectations. It's not good enough just to deliver more for less, but it needs to be sustainable, accountable, transparent, resilient. And then resources continue to be an issue in terms of labor, skilled labor, as well as materials, and in the heavy civil space, large capital equipment utilization. And finally, around data deficiencies, which are driven by two things. First, data silos, where we see about 30% of construction companies using applications that don't talk with one another, and also poor data quality, where 90% of the data is not structured, which makes it really hard to search for and unusable for analytics. The net of all of that is, while there's more and more data being made available for construction, only about 4% of that data is currently used, and the average construction firm spends about half a day a week just looking for it so they can do their jobs. A new potential impact is really around the construction productivity, is this long-term impacts that we might see or can look at in terms of what the coronavirus is doing to how we're going to work on construction projects. So health and safety on the job site will add a new dimension, and construction firms are really going to look at, you know, who is essential, which personas are essential to be on the job site. And so virtual construction may become more prevalent. Again, but to wrap up, the lack of productivity gains in this new normal won't be resolved by doing things the same way we've been doing them. We need to change our processes. We need to apply the latest in technology. So I'm going to describe again how the construction project digital twin can help address this. But let's start by defining what is a digital twin. There are probably some other definitions out here, but the way we look at it is first a digital representation of a physical asset, process, or system, and all the engineering information that goes with that digital representation, so that we can better understand it and model its performance. And then second, you know, once you have that model or digital twin, it could be continuously synchronized from multiple sources, including sensors, continuous survey from the field, and near real-time status, so you can understand what is happening, like I said, in near real time. So basically, if you're familiar with BIM or VDC, this is how do I take that the next step further and have a live BIM model for construction. So, and then last, you know, if you've got this digital twin, it now enables these data-driven workflows, including asset visualization, progress tracking in the field, performance analysis and insights, in order to predict and optimize better project outcomes. So let's start to review how we could use this digital twin, or the construction project digital twin, to solve the problems that we see in construction. So what if a digital twin could help you know where you are in a project by providing real-time data visibility in context, in leveraging and also providing a single source of truth, so that everyone on the job is on the same page at all times? And what if it could help us know where we are going by providing capabilities such as 4D planning and simulations, and model-based cost, quantities, and estimation, so that resources can be optimized, risks are mitigated, and projects are delivered on time. And then last, know that we're going to be able to get there faster by providing operational efficiencies and business insights and intelligence, so that teams make better, faster decisions and get more time on their side. So, you know, to summarize that thought, it's really about, you know, the digital twin having the potential to transform the way construction projects are delivered. So that means delivering them by providing continuously updated and live single source of truth for a construction project, and enabling transformative construction workflows such as 4D scheduling, 5D estimating, and machine automation, which I'm going to bring up again. So let's dig into how this value is achieved. So the digital twin is made possible today because of the advancement and convergence of several technologies. This includes the ubiquity of mobile devices out in the field, drones, robotics, reality capture, all on the job site, as well as the emergence in general of technologies such as artificial intelligence, machine learning, the Internet of Things, and mixed reality. So when you connect all these technologies with a 4D model, it really enables this concept of the construction project digital twin. So now that we have the basics of what the definition of a digital twin is and the high level benefits, let's take a step back and look at the full view of what a digital twin really encompasses. So first, everyone should understand there's really no one digital twin. There's multiple twins throughout an infrastructure asset. And each twin at each phase has specific workflows that benefit from that digital twin. For example, the design project digital twin includes really existing condition information models and the creation of the design models themselves. But doing that in the concept of a digital twin mode better enables design delivery and collaboration of that WIP process. Obviously, there's also a construction digital twin. I've said it numerous times, but we're going to talk about that a little later. But before I do, probably where we see the digital twin a lot today is in the asset, what we call the asset performance digital twin, where they're leveraging as-built models and real-time performance sensors and data and feeds to better maintain and operate assets. So each twin also really works off of the other. So the information from one twin, from planning to construction to asset management operations, builds on top of each other. But as I described, I'm really going to focus with that background as the background on the construction project digital twin. Okay, so now that we understand what the construction digital twin is, it's some high-level value propositions. Let's work through the steps of, well, how do I get there? How do I create a digital twin and then best leverage it? So, as shown kind of here in these slides, these bullets right here, step one really involves gathering existing condition model information, typically starting with the design models from the design authoring tools, and aggregating that information, as well as aggregating design model data with reality capture data, and putting that in an accessible data environment. In what we would recommend is to provide that in the cloud where it is the most accessible. So next is step two would be how do we transform this model into a construction model? And typically we would need workflows such as a model splitting of objects so that we have every asset is broken up into constructible components that better represent the way that object is actually going to be constructed. So at this point, if you've done that, the model is ready to be used for construction planning, simulation, and process optimization. And then step three, once we have this model, it's componentized for construction. It's all about adding construction attribution data. So the context is key if you're trying to execute on the delivery, which would be things like construction work breakdown structures, cost breakdown structures, the systems, and then applying during, say, the pre-construction planning phase, 4D schedule data and quantity information to the model. So this model could then be connected in step four to all the live feeds from the construction site, whether that's sensor data or kind of crowdsourcing near real-time information with the latest mobile applications to basically create this live digital twin model. And then ultimately it's about step five, which is how do I do workflows throughout the life, from pre-construction planning to execution, operations, and handover of a project. So how do I use this live model and leverage the other technologies we mentioned around analytical tools, artificial intelligence, and augmented reality and virtual reality to provide better decision-making and faster access to data via the model. So as we look at these steps, it's really about, again, these steps deliver the construction digital twin. And as you can see the digital twin here on the left, it really is also, you have to understand the inputs and outputs. And all the inputs are the feeds and the creation and the data that goes into creating the model in the first place. And the outputs are, again, the workflows that become enabled by the digital twin, as well as workflows that become transformed by the digital twin. And that includes things that we're going to talk about from pre-construction planning to operations, including 4D planning and simulation. We'll go into 5D modeling and quantity takeoff and estimation with the model. Progress in real-time resource tracking against the model, And then task-based or even project management workflows, such as how do I manage issues, RFIs, change orders, daily logs, and even inspections in real time against the model. And then other transformative workflows that, like machine automation and robotics, that would not be possible without having a model in place. And then ultimately, the digital twin is part of a common data environment, again, to deliver business intelligence and live reporting. The result of all this should be a step function improvement in the way construction projects are delivered. Okay, so let's get into some of the details now and real examples of how we create this construction digital twin. So what you're seeing here is, again, step one, where we're aggregating and sharing data in the cloud. And for Bentley, that means bridging reality model data and design model data into a database we call the iModel, hosted in a cloud environment called the iModel Hub. And in this example, you're seeing a huge civil infrastructure project where you're seeing the design model, photogrammetry turned into mesh models, as well as point cloud models, easily viewed in a web-based model viewer, streaming live from that iModel Hub cloud database. And it includes not just the geometry, but all the engineering data that came with it. So I want to take that aggregated, shareable data now and turn it into a construction model. So in order to take that design model into construction, it needs to evolve. So in the example I'm going to share is a product that we call Syncro 4D, construction modeler. It's a new solution that, again, it provides in this case, provides a really simple viewer that's shows the aggregate model information in a simple interface that's meant not for a someone who's familiar with doing CAD and BIM model authoring, or as a specialized VDC engineer, but any persona, non-CAD BIM professional, can use in order for them to take the steps necessary to evolve into a construction model. And that first is creating these constructible components by splitting solid and mesh model objects by phase, systems, or the means and methods that are critical to construction. So in particular, we're going to show this use case as a civil project, because that's where we see some of the most significant problems. If you're familiar with civil design authoring tools, model objects such as long linear corridor roadway or barrier wall come in as one long, large model object. It is nowhere close to the way it's going to be built. So the ability to split that up is critical, versus we see a lot of 4D modeling, for example, in buildings or industrial plant, where a lot of the model objects, like doors and windows, they know what they are and they're already in their constructible state, and data can be applied to them. And then I'll also show in this use case how in this environment we're able to apply construction attribution and ultimately end up with a model that enables downstream workflows that I've been talking about, such as 4D scheduling and work planning. But in this initial scenario, as I get to it, will be how do I do quantity takeoff based on the model. So what you're seeing here is a typical civil model brought in, and I can interrogate it in this simple environment, select model objects, see the engineering attribution that came from the design authoring. But now I want to be able to pull in a typical construction firm's work breakdown structure. So in this, you can do 6-7 levels of detail in that work breakdown and apply it to the model object. So that's interesting, but I want to split. That's, for example, in this retaining wall, this is not the way I'm going to build it. It's going to be built in, say, 2-meter lifts, concrete pours. So I'm able to quickly split the model, and now I have a number of lifts, and each one of these is its own model object now that is related to the parent object that was in the design model. As you can see in this cross-section view, the new splits, new model objects have come through. And they're each children objects, again, of the parent with their own identification and all the information from the parent, the engineering and the new work breakdown structures and cost codes and quantity information came over with the parent. So what you're seeing now is just the ability to report that quantity report in either summary or in its full glory, and both in the application and here shown in an Excel spreadsheet. So they can use it for to pull it into say your purpose-built estimating program. What we're also showing is how we link that data to other solutions in our portfolio and across other vendors' software. But the next step would be, okay, so now I've got a fully loaded construction model that's componentized for me, and I want to also be able to apply schedule data. So we're used to seeing 4D modeling tools. In this case, this is another application within our Syncro 4D environment that applies a schedule either built in the application or pulled in from other applications like P6 or ASSA or others, so that I could do scheduling against the model and then simulate, as shown here, how my sequencing and staging is going to happen. So that allows me to better optimize my schedule and resources and make sure I make mistakes virtually versus when they happen in the field. The next step is to tie the 4D construction model to live feeds, as we've talked about, making it a truly live model in construction digital twin. In this example, we have a 62-story building that was under construction in London, where they merged the 4D model with the orchestration of work areas, logistics, and the schedule with the live site camera feeds. So the result, as you saw here, was the analysis of how the plan was doing in comparison to the actual results. We saw a history here, but you can imagine a scenario where I'm seeing live, I'm comparing the plan against live feeds in real time, and how that might impact the way I do work and make decisions out in the field and continue to plan. And another example of tying near real-time feeds is the use of mobile applications in the field to capture data in the context of the 4D digital twin. So on the right, you're seeing a Syncro field mobile application where you're basically doing inspections and issues to capture in the context of a form or a map. But here we're also showing it could be all those tasks can also be captured in the context of the model out in the field. And so that was a quick example of how do I capture the issue and reference it to model space and geospatial location, as well as the model object itself. Another example would be how can I use the model, in this case on the left, a building example, to do progress tracking in real time in the field. So a field user can orient themselves against the model, search for the model objects that they are either inspecting or doing a progress status check on, and then quickly change the status of that model object. So now I've got live feeds coming from the field in an easy environment for the field user, but it also is all stored in the cloud and visible in, say, a web project management system as well. So again, some of the final steps of realizing the value of this construction digital twin is the insights that we get in the project visibility and analysis, and the different views that I can capture in terms of looking at that data either in a 4D model view, augmented reality views, or virtual reality views. And in this example, the model again is being leveraged to investigate alternative scenarios in terms of my construction planning. But again, I can be back in the job, back in the office, viewing the data that I captured in terms of progress from the field and comparing the plan versus actual, and seeing my Gantt chart in real time here. So again, the benefits of this are, if I can see what's happening in the field against my plan, I could take action against that much more quickly and keep my project in control, on budget, and on time. And then this is just a quick example of some of the staging simulations that you can do if you had a 4D model and digital twin, to do rehearsals with crews before you actually try to do a complex logistical operation. And if I can move on, the digital twin can also be used as context for project management and managing most construction tasks and even administration tasks. In this example, we have a project management web surface, but it has the ability to access, manage, and create data in the context of the 4D construction model as shown here. So I'm now able to enhance my project management workflows, but also enhance the way users can access the data. So I'm more quickly able to find information I need based on selecting an area of the model and going to, since it's a 4D model, going to a specific point in time and just seeing the issues, RFIs, change orders, inspections, and other work plans and tasks in that context. And here we're showing the example of, even if I'm on in the web environment, in the office, and I'm virtualized, I still can assign issues and tasks directly to that digital twin in context of that digital twin model space or the object itself. So a really compelling way to transform even project administrative workflows. And then in this example, just a little more detailed demonstration of the scale at which we can interrogate construction models. So in this case, we're seeing all the context of the entire city in which the project is being done. But I'm able to interrogate that model, that 4D model in that city context, and then be able to move basically you're seeing the time slider on the bottom, be able to move the simulation back and forth in real time. But I'm also collaborating and streaming live over the cloud, so I can have multiple users participating in this kind of construction review session, and commenting in real time against it, and doing basically live chats and storing that stream and comments live. So this could be comments, but again, it could be those comments can be issues. We can also add RFIs and track other information in a real-time session as a collaboration. And then again, if we move on to things like machine learning and automation, we can actually train the software to detect information in the model. So if I'm doing, say, reality capture and I have a mesh, I can do not just photogrammetry detection of, say, in this case, equipment or machines, but I can actually do that same level of detection in a complete mesh. So I can understand what's going on in the project, and in this case, maybe detect equipment moves, but also detect new surfaces and do volume calculations, so I can track progress in real time using machine learning. And so I guess one of the last things I want to leave you with is the experience of and the ability to take the data into the field, that digital twin into the field through different devices, not just say a laptop or a tablet or iPhone, but also leverage things like the Microsoft HoloLens to do mixed and augmented reality. So in this example, what you're seeing is I'm on a job site with a HoloLens, and I'm seeing that 4D digital twin simulation overlaid on top of reality. And this is really useful when you're trying to, again, coordinate logistics and see where you are in terms of progress against your construction plan, and whether there's any issues that you're going to find as you move forward with your operations. So I hope all these examples show how to deliver the benefits of a construction digital twin, and it's all the technology is available to you today to deliver that. And for Bentley, we do that through Bentley's new Syncro construction portfolio. So take another couple minutes just to take a closer look at that Syncro portfolio that whereas most of the examples I showed were from this technology. It is really Bentley's latest construction portfolio as shown here, meant to be a broad set of integrated construction solutions, leveraging Bentley's core capabilities around data management and 4D modeling. But the result is the ability to deliver field management solutions against with native mobile applications. Syncro Control is our web-based project management offering and document control solution. Futures are a cost management offering, but the other probably most significant solution there is what we call Syncro 4D, which is our cloud and desktop offering for planning and virtual construction, which is used in both pre-construction planning and operations, but it's the tool that helps set the stage for the development of the construction digital project digital twin to do downstream workflows in the field and in project management web services. So again, it's an integrated broad solution, and it's really has three key strategies for us in Bentley, which is one is around managing data in project context, as well as which means those work breakdown structures delivered and other construction data delivered either in a web, in a dashboard environment, map, 3D, 4D, or 5D digital context, delivering that 4D digital project twin as a single source of truth, and making sure we connect workflows, resources, and the data so that, for example, you can connect different people, whether they're in the office or in the field, and connect those people together on those workflows. So that's where I wanted to end. Hopefully we didn't run too far over, and we have some time for Q&A.
Thanks, Rich. That was great. So I'll open it up to the floor if there's any questions. Looks like Daniel D raised their hand earlier. You still have a question, we can unmute your mic. And I don't see any questions in the Q&A. So feel free to type questions in there as well. So Rich, I have a question for you. Through your development trying to drive adoption of digital twins, what do you see as the major challenges in adoption?
Of the digital twin?
Right.
I think there's probably two main obstacles. One is just realization in the availability of the technology, which hopefully I think we've shown in this presentation is now actually available, right? So the technology exists, although sometimes it's disparate and it requires some effort to pull it together. So I think Bentley and other vendors are taking that task on to be able to package all the technology together in a purposeful way, so that the construction digital twin becomes just off the shelf. I think as part of that, the development of the ability to aggregate all the models into a single cloud environment and then connect it to live sensor feeds is what we've really resolved. But the other big obstacle is really just culturally within construction itself, right? There's always been this kind of thought of, if it's not broken, don't fix it. So it's really around how do we change what we're used to doing and move on to new processes, because this isn't just do the same work the way we've done it, but now let's do it in a digital manner. A lot of the workflows are going to be the same, but with a model context. But a lot of where you're going to get step function improvement is around process change associated with the technology, and that's never really an easy thing to do in the AEC environment where engineering and construction engineers are sometimes conservative and don't like the change.
Right. Yeah, I think we saw that a lot with BIM adoption.
Yeah.
So it's
It's just another evolution really of BIM and its application into construction and making it a living model. But it's an adoption process for sure, and it takes education.
Right. Great. So we have a question from Dan now. How do we make the process cost effective?
Yeah. So I think it all comes down to the technology. I think in the past it was expensive because you had to pull different technologies together from different vendors, and then the process of pulling together a digital twin and connecting it up was a consulting services engagement. And I think if hopefully you're seeing where we're going today is like Syncro, for example, enables a construction digital twin with a lot of off-the-shelf capabilities and a user experience that's meant to be simple to do, right? So you could get Syncro and be up and running and with a construction digital twin and off-the-shelf workflows without a lot of cost, almost in near real time, because it's only cloud SaaS-based offerings. There's still going to be some work, right, in translating the design model to a construction model, and hopefully we've solved some of those problems. But there's always a little bit of work to aggregate and make sure that the models come in the right way. So I think it's changing. I think as the technology starts to merge together, with including open source access to data, that cost of the technology will come down, and the amount of effort that goes into it will also come down.
Okay, thanks. So on that note, we're talking a lot about sensors and things like that. Are you able to work with any type of sensor, or are there specific protocol you need?
Yeah, no, I think some of the sensor data is often kind of standard, the way the information comes off those. So through open APIs, we're able to read in most sensor data.
Okay, great. So we have a question from Tanwar. Can we use it for smaller scale projects as well?
Yeah, I mean, absolutely. I think that's the other good thing about the way the technology is starting to evolve and emerge is that there's a lot of value that comes out of a large complex project, but the way Bentley, for example, has delivered our solutions is it scales from very large complex projects all the way down to the smallest basic projects as well, because the model, even if it's a small simple model, adds a lot of value to even small projects. So yeah, it scales all the way down from up and down in terms of project size and complexity.
Great, thanks. We have another question from Dino. What are key issues for architects and engineers during the design phase preparation of the design model in order to effectively feed into the later phases of the digital twin development process?
Yeah, I think so. Two things I'd say. One, Syncro, the Syncro modeler technology we built was meant to kind of make it so that the architect and engineer didn't have to really think too much about the constructability of the model, and that a construction persona could then take any design model and turn it into a construction model for their purposes. That said, I mean, everything gets easier if the architecture and engineer work with their construction partners that understand the way they want to have the data come in. I mentioned, I showed in my use case the ability to apply work breakdown structures and other construction attribution, but you could set up the model in a way that is easier to pull in instead of potentially include some of that construction attribution already applied to certain model objects, and that would go a long way to speeding up the process. So I think we've talked to a lot of customers about that, particularly when it's a design build JV and there's a lot of collaboration, and where they can get the most benefits in terms of how to prep the design model so that it doesn't become a lot of effort to connect it all together in the construction phase. But so hopefully that helps. Definitely you have to go and talk to your construction partners and find out how what is their specific data formats that they have for their processes, and whether or not it can be applied early on in the design phase.
Great. So I think we have a little time for one quick more question. What is your advice for current industry professionals who want to make a career shift to the digital twin era on an individual level?
Okay, well, I guess I would first thing would be to embrace technology, right? So I think you have to understand as someone new to the industry, what the workflows are and how buildings and infrastructure and roads get built today and what the processes are, but don't be encumbered by how things are done today, and become a technology expert. Learn as much as you can about the available software and how leading edge companies, and even there's some obviously leaders as individuals out in the market that are always constantly pushing the edge for how software tools and technology are being utilized, and then don't accept the current status quo workflow. Figure out, okay, I know how to use the technology. This is the way I think things should be done, and go experiment and try to make it happen.